Hello, welcome back. We were discussing Chapter 9 Sequences and Series of Standard 11 Mathematics NCERT textbook. Today we can discuss the section Arithmetic Progression AP. So we can go to the video. You already studied arithmetic progression in 10th standard. We can see consider a sequence of even natural numbers. Say 2, 4, 6, 8, 10, etc. Here first term is 2 or a1 is equal to 2 and second term is 4 obtained by adding 2 to first term, or we can write a2 is equal to a1 plus 2 and a3 is obtained by adding 2 to second term a2, or a3 is equal to a2 plus 2, etc. And an is equal to, we will get it as an minus 1 plus 2. Or generally consider a sequence a1, a2, a3, etc., an, etc. This sequence is called an arithmetic sequence or arithmetic progression if an is equal to an minus 1 plus some d. An is equal to an minus 1 plus d for n belongs to n. Or arithmetic sequence is a sequence obtained by adding a fixed term or a constant term d to the preceding terms. And this constant term is called a common difference. See, we can write a sequence a1, a2, a3, etc. an is called an arithmetic sequence or arithmetic progression if an plus 1 is equal to an plus d for n belongs to natural numbers, where a1 is called a first term and the constant term d is called the common difference of the AP. Now consider an AP with the first term a and a common difference d. Then what will be the arithmetic progression? First term a, second term a plus d, third term a plus 2d, etc. Here see, second term is a plus 1d, third term is a plus 2 into d, etc. What we will get the nth term? Nth term an is equal to a plus n minus 1 into d. So the nth term or general term of the AP is an is equal to a plus n minus 1 into d. Now we can discuss some simple properties of AP. We can discuss it by considering an AP, say 2, 4, 6, 8, etc. Sequence of even natural numbers. See, the first property is if a constant is added to each term of an AP, then the resulting sequence will also be an AP. See, we can add a constant, say 3 to each term. Then the sequence will be, we are adding 3 to each term, 2 plus 3, 5, 4 plus 3, 7, 6 plus 3, 9, 8 plus 3, 11, etc. Here see, it's an AP with a is equal to 5 and d is equal to same 2. 7 minus 5, 2, 9 minus 7, 2. Here the common difference does not change. Here d is equal to 2 and here also d is equal to 2. We can say it in general. Second property is if a constant is subtracted from each term of the AP, then the resulting sequence will also in arithmetic progression. Say we can consider the constant k is equal to 1. Then the AP will be 2 minus 1, 1, 4 minus 1, 3, 6 minus 1, 5, 8 minus 1, 7, etc. Here D is equal to 2 and A is equal to 1. This is an AP with A is equal to 1 and D is equal to 2. Just first term changes and consequently the next terms, but not the common difference. Now the third property is, if each term of the AP is multiplied by a constant, then the resulting sequence is also an AP. Say we can multiply by some 2 itself, then the sequence will be 2 into 2, 4, 4 into 2, 8, 6 into 2, 12, 8 into 2, 16, etc. Here A is equal to 4 and D is equal to 4. This is an arithmetic progression here. Common difference changes. It's also multiplied by 2. Now the fourth property is, if each term of the AP is divided by a non-zero constant, then the resulting sequence is also an AP. We can divide it by some 2 itself. Then the sequence will be 2 by 2, 1, 4 by 2, 2, 6 by 2, 3, 8 by 2, 4, etc. Here this is an AP with A is equal to 1 and D is equal to 2 minus 1, 3 minus 2, 1. Remember the notations: A equal to the first term, L equal to the last term, D equal to common difference, N equal to number of terms, Sn is equal to sum to n terms of AP. Now consider the AP A plus D, A plus 2D, etc. A plus n minus 1 into D. Here what is the first term? First term is A, common difference is D. And number of terms here is total n terms, n minus 1 plus 1, n terms. And see what is the last term here, A plus n minus 1 into D. What is Sn? Sum to n terms. You already studied in your previous class. Sn is equal to n by 2 into 2A plus n minus 1 into D. Or we can say A plus n minus 1 into D, or A plus L. Or we can say n by 2 is A plus L. See how we obtain this formula. Here we have a sequence A plus D, A plus 2D plus etc. Then what is Sn? Sn is equal to A plus D plus A plus 2D plus etc. plus A plus n minus 1 into D, which is here A n times. 1 time, 2 times, etc. n times. We have A n times. This is n into A plus, now take a D common here, D into, we have 1 plus 2 plus etc. plus n minus 1. 1 plus 2 plus etc. plus n minus 1, which is equal to n A plus D into sum to n minus 1 terms of natural number. We know the formula for sum to n terms of a natural number. 1 plus 2 plus etc. plus n is equal to n into n plus 1 by 2. You already studied this in your lower classes. So we can substitute here. Instead of n, we have n minus 1. N minus 1 into n minus 1 plus 1 is n by 2, which is equal to 2 into NA plus n into n minus 1 into D divided by 2, which is equal to, here n is common, n by 2 into 2A plus n minus 1 into D. Just keep this in mind. We need this formula only. Sn is equal to n by 2 into 2a plus n minus 1 into d. This is important. Now we can see some examples. See the example. In an AP, if mth term is n and the nth term is m, where m not equal to n, find the pth term. Given am is equal to n and an is equal to m. Mth term is n and nth term is m. We have to find pth term. What is pth term? AP is equal to a plus p minus 1 into d. So, to find pth term, we need the first term a and the common difference d. We have given mth term and nth term. From this, we can obtain first term and the common difference. What's the formula for am? Mth term is equal to a plus m minus 1 into d. That is a plus m minus 1 into d is equal to n, and a plus n minus 1 into d is equal to m. Now we can solve these two equations. Let it be 1 and let it be 2. Now 1 minus 2 is a minus a 0, m minus 1 minus n minus 1 into d, or d into m minus 1 minus n minus 1, which is n plus 1, by removing the bracket, which is equal to n minus m, which is d into minus 1 plus 1 is 0, m minus n is equal to n minus m, or minus of m minus n. Therefore, d is equal to minus of m minus n divided by m minus n, that is minus 1. So, we obtain the common difference. Now, to obtain the first term, substitute in 1 or 2. We can substitute in 1, d in 1. 1 implies a plus m minus 1 into d is equal to minus 1 is equal to n. This is a minus m plus 1 into minus 1 minus m plus 1 is equal to n. Which is a is equal to n plus m minus 1, or m plus n minus 1. So we have first term and a common difference. Then to find the pth term, substitute a and d here. Now the pth term is, instead of a, m plus n minus 1 plus p minus 1 into, instead of d, minus 1, which is m plus n minus 1. Here p minus 1 into minus 1 is minus p plus 1. Minus 1 plus 1 is equal to 0, which is m plus n minus p. Therefore, the pth term is m plus n minus p. Next example. If the sum of n terms of an AP is np plus 1 by 2 n into n minus 1 into q, where p and q are constant, find the common difference. Here, sum to n terms, Sn is given. We have to find the common difference. Before going to the solution, see, let a plus d, a plus 2d, etc. be an AP. Then what is S1? S1 is sum to first term, a, first term itself. Then what is S2? S2 is equal to first term plus second term. Sum to two terms, first term plus second term, that is a plus d, which is equal to 2a plus d. Now, to obtain common difference, we have 2a plus d minus 2a. That is, a is S1, therefore 2a is 2S1. Therefore, we can write d is equal to S2 minus 2S1. Here, d is 2a plus d minus 2a, but a is S1, therefore minus 2S1. That is S2 minus 2S1. We are using this concept to find the common difference here. See, we have Sn is equal to, given np plus 1 by 2 n into n minus 1 into q. Therefore, we can substitute n is equal to 1 to get s1 and n equal to 2 to get s2. Now s1 is equal to p plus 1 by 2, 1 into 1 minus 1 into q, which is equal to 0. Therefore, s1 is equal to p. s2 is equal to 2p plus 1 by 2 into 2 minus 1, 2 into q, which is 2p plus q. Therefore, common difference s2 minus 2s1 equal to 2p plus q minus 2 into p, which is equal to q. Therefore, the common difference is q. So, if we have given Sn and we have to find the common difference, we can use this method. Or, we already know the formula for Sn, n by 2 into 2a plus n minus 1 into d. Given Sn is equal to this one, np plus 1 by 2 n into n minus 1 into q. We can equate these two equations and we will get the common difference. I will do this method in some other questions. Or, let a1, a2, etc. be an arithmetic progression. See, S1 is equal to A1. S2 is equal to A1 plus A2. What is D? D is equal to A2 minus A1. Common difference D is equal to A2 minus A1. Here we have got A1. Then what will be A2? A2 is equal to A1 plus A2 minus A1. That is S2 minus A1. That is, we have got A1 and A2. Then common difference will be A2 minus A1. You can use any method that is easy for you. Okay, we can see the next example. Next example, the sum of n terms of two APs are on the ratio 3n plus 8 is to 7n plus 15. Find the ratio of their 12th terms. We have given sum of n terms of two APs. See, sum of n terms of first AP by sum of n terms of second AP is equal to, given their ratio 3n plus 8 is to 7n plus 15. That is 3n plus 8 by 7n plus 15. This is given. We have to find the ratio of their 12th term. That is, if the first AP has the first term a1 and a common difference d1, and also the second AP has first term a2 and a common difference d2, we can write a1 plus 11 d1 by a2 plus 11 d2. 12th term is a1 plus 11 d1. We have to find this ratio. See, we know the equation for sum to n terms. So, sum of n terms of first AP is n by 2 into 2a plus 2a1 plus n minus 1 into d1 by n by 2 into 2a2 plus n minus 1 into d2, which is equal to 3n plus 8 by 7n plus 15. See, n by 2 gets cancelled. So, we get 2a1 plus n minus 1 into d1 by 2a2 plus n minus 1 into d2 is equal to 3n plus 8 by 7n plus 15. See, we have to find a1 plus 11 d1 by a2 plus 11 d2. We have 2a1 plus n minus 1 into d1 by 2a2 plus n minus 1 into d2. Here, see, we can substitute n minus 1 is equal to its double, 22, or n is equal to 23. Then we will get, see, put n is equal to 23. Then what will 1 becomes 2a1 plus 22 d1 by 2a2 plus 22 d2 is equal to n is equal to 23. Therefore, 3 into 23 plus 8. We will get it as 77 by 7 into 23 plus 15, which is equal to 176, which will be equal to 7 by 16. Here 2 is common, take 2 outside, then we will get 2 into a1 plus 11 d1 by 2 into a2 plus 11 d2 is equal to 7 by 16. See, 2 gets cancelled, that is a1 plus 11 d1 by a2 plus 11 d2 is equal to 7 by 16. Therefore, the ratio is 7:60. Next example, the income of a person is rupees 3 lakh in the first year and he receives an increase of rupees 10,000 to his income per year for the next 19 years. Find the total amount he received in 20 years. Here in the first year his income is 3 lakh and in next 2 years he received an increase of 10,000 rupees for 19 years. We have to find the total amount after 20 years. So that is, here A is equal to 3 lakh and B is equal to 10,000 and we have to find Sn for n is equal to 20 years. So we have to find Sn or S20. We know the formula. Sn is equal to n by 2 into 2a plus n minus 1 into d. Therefore, S20 is equal to, put n is equal to 20. 20 by 2 into 2a plus n minus 1 into d. Instead of a, 3 lakh. 2 into 3 lakh plus n minus 1 is 20 minus 1, 19 into d is 10,000. Which is equal to 10 into, this is 6 lakh plus this is 1,90,000, which we will get 79 lakh. Therefore, we can say that he receives this amount after 20 years. Total of this much amount. It remains a small section, arithmetic mean. We can discuss it in the next video, and also we can see some more exercises. Thank you.